Okay, so for my recitation of Math 1553, so that's sections A5 and E3, I gave some additional exercises and in addition to the ones on the worksheet. So the first two was asking you to solve a system of linear equations. The first one is 2x1 plus 5x2 plus 3x3 is equal to 9. x1 plus 2x2 plus x3 is equal to 4. 4x1 plus 9x2 plus 5x3 is equal to 8. So we need to solve this one. The second problem is x1 plus 2x2 minus 3x3 is equal to 5. 2x1 minus x2 minus 8x3 is equal to 6. And 5x2 plus 2x3 is equal to 4. And the last question is asking whether or not a certain equation is a linear equation, and why. And it is 5x1 plus 2x2 minus 3x1 times x2 is equal to 7. So please attempt these problems before looking at the solutions, and I'm going to go work them out right now. So, the first problem. We have the following system of equations. And what I'm going to do is, since not everyone has seen the augmented matrix form, I'm just going to solve it the normal way, even though it might take a little longer. So, what I'm first going to do is I'm going to rewrite this system and switch x1 and x2. So, or switch, if this is equation 1, equation 2, and equation 3. So E1, E2, and E3 this is my way of denoting which equation it is. So we're going to switch them. And so switch. And then we get our system is x1 plus 2x2 plus 3, plus x3 is equal to 4. So we're just writing our second equation in place of the first. And then we have 2x1 plus 5x2 plus 3x3 is equal to 9. And then our third equation is 4x1 plus 9x2 plus 5x3 is equal to 8. So, well, our first goal is to eliminate the x1 from these two equations. So to do that, I'm going to say, all right, equation 2 is equal to equation 2 minus 2 copies of equation 1. And equation 3 is equal to equation 3 minus 4 copies of equation 1. And doing that, we get the following. So our first equation stays the same, x1 plus 2x2 plus x3 is equal to 4. So when we subtract 2 copies of the first equation from the second, our x1's cancel out. And we see 5x2 minus 2 times 2x2, so that's 5x2 minus 4x. 4x2 is just 1x2, so we have an x2 here. And then we have 3x3 minus 2x3, so that's plus x3 is equal to 9 minus 2 times 4, so 9 minus 8 is 1. And then we have to subtract 4 copies, and since we have 4x1 minus 4x1, we get 0x1 there. Then we have 9x2 minus 4 times 2 is negative 8x2. So 9 minus 8 is 1. So we have a copy of x2 here. Then for here, we have 5x3, and we're subtracting 4x3. So we have plus x3. And then this is equal to 8 minus 4 times 4. So 8 minus 16. This is equal to, let me just make sure I'm doing the algebra right, because -4, so this is a -16 added to 8 gives us a -8. All right, we're almost done. So the thing you need to notice is these two equations right here. So our new E2 and our new E3. We have x2 plus x3 is equal to 1, and x2 plus x3 is equal to -8. So there's one way you can think about this, and you can say you're done right now, is you're saying, how can we have, since x2 plus x3 is equal to 1, and x2 plus x3 is equal to -8, that means 1 is equal to -8, which is nonsense. So here you can say it's an inconsistent system. Or you can even go further and say, all right, we're just going to say our third equation. So equation 3 is just equation 3 minus equation 2, with this is our E1, E2, and E3 for this operation. So the first equation will stay the same. The second equation will stay the same. And then since we subtract, we get 0 is equal to -8 minus 1 is -9. And since we have 0 is equal to -9 here, that doesn't make sense. So we have our system is inconsistent. So you can say inconsistent system. No solutions. All right. So now we have our second problem. So x1 plus 2x2 minus 3x3 is equal to 5. 2x1 minus x2 minus 8x3 is equal to 6. And 5x2 plus 2x3 is equal to 4. So we're going to do the same thing. We're going to call this one E1, this one E2, and this one E3. So the E just means equation. So, well, we want to cancel out this x1 here. So we're going to do the following. We're going to say, all right, our second equation is going to equal our original second equation minus 2 copies of our first. And in doing so, our first equation stays the same. So our second equation is the only one that changes, and the x1s will cancel out, and then you're going to see you have what is that? Negative x2 minus 4x2, so that's negative 5x2, and then negative 8x3, and it will be a plus 6x3, so that gives us negative 2x3 is equal to what is that equal to? 6 minus 10 is negative 4, and our third equation also stays the same. Now, right here, you can do the following. You can notice that this second equation, so our new E1, E2, and E3, our second equation is just negative 1 times our third. So you can say, all right, we can just say E3 is equal to E3 plus E2, and this will give us the following system. x1 plus 2x2 minus x3 is equal to 5. Negative 5x2 minus 2x3 is equal to negative 4, and 0 is equal to 0. Now, the difference here for this system is since we have a 0 is equal to 0, we're not inconsistent, because 0 is equal to 0. So we're actually able to solve this. But since we aren't able to say what x3 is, like we can't say x3 is some number, we're going to treat x3 as a variable. So x3 will vary. So this is actually going to be a line. So this is a line. In R3, I don't know if you've seen this notation. That just means three-dimensional space, because we have x1, x2, and x3. So how do we figure out what this line is? Well, let me get some more paper. So this is 2 continued. So we have the following two equations that we're working with. x1 plus 2, x2 minus 3x3 is equal to 5, and negative 5x2 minus 2x3 is equal to negative 4. So we're going to solve for x1 and x2 in terms of x3. So this x3 here is what's known as a free variable. Basically, we let it vary. So x2. So if we call this one e1 and e2, we'll use equation 2 here to solve for x2 in terms of x3. So using e2, we get, so negative 5x2 is equal to negative 4 plus 2x3, and then you have to divide by negative 5. So this gives us that x2 is equal to 4/5. That's from this first one. And then minus 2/5 x3. All right, so we know what x2 is in terms of the x3. So now we can actually solve for x1 in terms of x3. So using equation 1, and that x2 is equal to 4/5 minus 2/5 x3, we get that, what do we get? x1 plus 2, well, x2 is equal to 4/5 minus 2/5 x3 minus 3x3 is equal to 5. So let's distribute this 2 out. So we get x1 plus 8/5 minus 4/5 x3 minus 3x3 is equal to 5. So moving everything over to the right-hand side, we get x1 is equal to 5 minus 8/5 plus 3x3 plus 4/5 x3. Or you can simplify this. So this would be 25 over 5 minus 8. So 25 minus 8 is 17/5 plus, that would be 15, so 19/5 x3. So what is your solution? Your solution is the line is a line. And you can describe the line in terms of its x1, x2, and x3 coordinates, and you can actually do it in the following way. So what is, we know, so you can say it's the line given by, we're putting it in parametric form. So 17 over 5 plus 19 over 5, we'll just call it t. So that's what our x1 is. Our x2 was 4 over 5 minus 2 over 5t, and our z coordinate was t. So you can, or x3 coordinate is t. So you can just think of this t right here as your x3. And so this will describe a line in 3 dimensions. All right, so that's the solution to number 2. So the last problem is, where is the last problem? Oh. here it is. So we're just asking, is this equation linear? And this one is just a quick one. It's no. Because we have the negative 3x1, x2 term. And even though you can think of x1 as linear and x2 as linear, but when you multiply them together, it's not linear anymore. Since you are multiplying two variables. So you don't want to multiply two different variables when you're dealing with linear systems. So yeah, that was just the 3 additional problems I had. All right, good luck.